Hi all, welcome back to my channel. I'm Sivathmika Chavali. If you are new to this channel, please make sure to subscribe to my channel and hit the bell icon. This is day 18 of being productive in coding. Today I'm gonna solve breadth first search of graph. Basically, I have already completed breadth first search of binary tree. Please check out that video and I will give that video link in the description box as well as in this iCard. This one in this iCard. So let's do BFS of graph. Basically, graph follows two techniques, breadth first search and depth first search. These are the two techniques to traverse the graph. Breadth first search, in the sense, it is level order traversal, like how we traverse the binary trees in level by level in that video, in the past video. In the same way, graph in that level order will be continued in the graph also. That means this is breadth first search. Breadth wise, we will traverse the graph here. Let's take this example. Here they have given one adjacency list. See, in Java, they have provided adjacency list. In that adjacency list, we can see this is the zeroth index, right? So what is the size of this adjacency list? 0, 1, 2, 3, 4, 5. 5 is the size of the list. Here, 0. Zeroth index neighbors are 2, 3, 1. In that way, they will give the adjacency list. That means for zeroth index, these are the neighbors. For one index, these are the neighbors. For second index, the neighbors. In that way, the adjacency list follows. And they have given pictorial representation of the graph for our understanding purpose. You can see 0 index are connected to 2, 3, 1, and 2 is connected to 4 and also 0. For that's why you can see 0, 1, 2. For second index, you can see the connected neighbors of 2. 0 and 4 are the neighbors of 2. And for the third index, that means third node, only the 0 is the neighbor for third node, but that's why you can see 0 is there for it. And coming to the last one, that is 4. 2 is the only node that is connected, and that means 2 is the only neighbor for 4. So this is the representation of adjacency list that they will give, and we need to return the output in the level order wise. See, this is the level 1, and this is level 2, and this is the level 3. In level wise, we need to print as our output. This is so 0, 2, 3, 1, and this is 4. Oh, sorry, these all are level 1, level 2, and the last 4 is the level 2. Okay, it's my bad. 1, 2, 3. Okay, because the distance between them is only 1, right? See, this and this is 1 distance, and up to this one is it is going to the second distance. So this 4 alone will comes to the third level. I hope you are all getting. In this way, we need to print in the level wise. For this, we can first initialize the visited word. Visited new int the size of the given adjacency list. Why we are using visited array means to track the nodes. If the node is if the node is already visited, means we are not going to visit it again. If the node is has to visit means we can visit. So for tracking purpose, we are initializing the visited node, and then we need to return the output as array list. So let's initialize one resulting array list integer new array list, and then so our visited array is created, and we also initialized the array. So where can we store all these nodes? We can store it with the help of queue data structure. Queue data structure follows FIFO method, first in first out, so we need to use that one. Even in the binary tree level order traversal, we use a queue data structure. Please check out that video. Okay, now we need to initialize the queue. All these nodes are integer type, so integer queue equal to no linked list. Now everything was initialized. Now we have to start our main programming. So we have initialized the queue. First we need to node will be always starting from 0. Starting node is always 0. You can see they mentioned here starting from vertex 0. So 0 is the our starting node. From 0 we need to start everything connecting. Everything should be connected. Okay. So from 0, for that's why we need to add the 0 in the starting itself, as we already visited this node. It's already in the queue. So we need to mark our index visited. We created one visited array, right? So we need to mark our visited array to 1. That means the 0 index is already visited. 1 here represents it is already visited. Okay, in future purpose, for tracking purpose we created. Now while loop will start. While q dot size is empty, we have this function method. So q dot is empty. Q should not empty. If it is empty means while loop will be stop. While loop will stop its execution right there. Now as q is already there, one node is there now, 0. It will execute this while loop. Now let's say int n equal to, now wait 1 second. Now 0 is there, right? Now we need to poll that element, poll that node that is present in the queue. Queue has 0 as its first node. Now we are what we are going to do means we are removing that node from the queue. See, for that's why we are taking queue dot poll. We are removing that one and we are printing into our list. So we are adding into our resulting list. A dot add that n. In that way, our output list will print 0 as of now. Now, we should open the for loop. We have to write for each statement. For each I adjacent dot get n. See, I will explain you. In int n, please listen carefully. In int n, the q dot poll, in q 0 is there. So n will take the value 0, n equal to 0 here. Now a dot add n. In array list 0 will be printed, 0 will be added. Okay, up to here it's clear. Next one, for loop is going to execute here. For int every element in adjacent dot get n. See here n is 0. Adjacent dot get 0. This is the adjacent list that they will give. So adjacent dot get n, get 0. This is the 0 index, get 0. What are the elements? These are the neighbors 2, 3, 1. So for each and every element, I will holds each and every element that is present in adjacent dot get of whatever the value of n is there, that n. I hope you are all getting. So now I holds 2, 3, 1. But we need to write one condition. If the visited array of I is equal to 0, if it is not visited means then just make it as visited, because we are visiting now, visited, and add that element into our queue. I hope you are all getting. See, we are grabbing these 3 neighbors and we are initializing those 3 with equally with the I variable here. Now visited of 2. See, we only visited 0th index up to now. Now visited of 2 is 0, right? Initially it is 0. So that means that second index is not yet visited. So now we are marking it as visited. Yes, second index is visited. Now we are going to add the 2 into our queue. So our queue is holding only one element, that is 2. 0 is polled, right? 0 is removed. Now 2 is added, and the next loop, 3 will be executed, and for 0 in for 3 index also in visited array it is not yet visited, so it will mark it as 1 now as it is visited now, and it adds q. In q 3 will be added again. So now two elements are there, 2, 3, and again 1 will be executed. Now 1 will add it. 2, 3, 1 are added now. And the next while loop will be executed, int n equal to q dot poll. Now q dot poll, first in first out, right? What is the element that is added first? 2 is added. 2 will be removed now. So in the place of n, 2 will be there here, and a dot add 2 will be printed here in our array list. Now again for loop will start. Now it will fetch adjacent dot get of 2, as our n value is 2. So it will fetch the second index of our adjacency list, 0, 1, 2. Now the neighbors will be 0 and 4 here. But here comes the challenge. What is the challenge? But we are already handling, right? See, 0 is already visited. If for 0 index it is 1, right? But it is saying only if it is 0, we need to use this if condition. So 0 will not again adding into the queue. But that's why we are using visited array. I hope you are all getting. So this is the way we need to track the breadth first search. We need to traverse the breadth first search, and now we need to return the our resulting array. Let's compile and run. Actually the same process will go through with this all the indexes. If it is visited means it will not touch that one. If it is not visited means it will go and visit. That's it. Now our code is compiled. Now let's submit the code. So it's passing. In this way we need to solve this problem. So yes, I have completed the day 18 of this product 2 series. This series is only meant for me. Like I don't want to share any kind of knowledge that is there for me in coding. Actually, I'm just learning myself. I just want to improve myself in coding. Uh, Thank you for watching. Please do subscribe to my channel.